These are medium-speed marine engines. One is an inline engine, and next to it is a V-line engine. Both are 4-stroke engines. They're called 4-stroke because each piston completes a power cycle in 4 movements. Intake. Fresh air is blown into the cylinder. Compression. The piston compresses the air, making it dense and hot. Power. Fuel is injected, ignited by air compression and heat, and creates combustion. Exhaust. After the combustion, fresh air turns into exhaust gas and is pushed out of the cylinder. Unlike low-speed 2-stroke engines, 4-stroke engines do not use long piston rod. These engines can run on heavy fuel oil, marine diesel oil, or LNG in dual-fuel versions. The V-line engine produces about twice the output of an inline version. For example, an inline 8-cylinder model produces around 4,000 kilowatts. A V16 cylinder model produces about 8,000 kilowatts. Different models are designed for different vessels depending on their duties. Let's look at the main component of the V16 engine. Crankshaft, the first part that generates torque. Pistons and connecting rods are arranged in a V shape. Each crank web is designed with counterweight to balance the rotational and reciprocating forces when operating at the higher RPM. Cylinder liner and cylinder head. Each head contains 2 intake valves, 2 exhaust valves, and a central fuel injector. On the side is a starting air valve. The engine uses camshafts, push rods, rocker arms, and fuel pump. Each cylinder has 3 cam loops to open the intake valves, drive the fuel injector, and open the exhaust valves. The camshafts are synchronized with the crankshaft by gear chains to ensure precise timing. The engine is started by high-pressure compressed air from these starting air valves. This air pushes the pistons, turning the crankshaft until combustion becomes self-sustaining. In a V16 engine, this is the firing order. This order is not random. It is carefully designed to minimize the bending load and excessive stress on any one section of the crankshaft by distributing the combustion forces evenly along the crankshaft. Also, during each power stroke, the flywheel absorbs and accumulates energy, smoothing out the engine's rotational motion. The bottom frame of the engine is the bed plate, which holds the main bearings. The crankshaft rests on these bearings, supported by a layer of lubricating oil. Cylinder liners, cylinder heads, cooling water line, exhaust gas manifold, charging air manifolds, Cylinder block. Camshaft covers. Relief valves. These are for releasing pressure inside the crank spaces. Twin turbochargers. Oil sump and manifold heat shield. After the combustion, exhaust gas leaves the cylinders and flows into the exhaust manifold. The hot gas spins the turbine inside the turbocharger. On the same shaft, the compressor side draws in fresh air from the engine room. Fresh air goes into the charge air cooler by passing through these water tubes and becomes cooler before entering the cylinders through the intake valves. The cooling system has two circuits. High temperature water cools the hottest parts, like the cylinder liners and heads. Low temperature water supports components such as the charge air cooler and some other parts. The lube oil system pumps oil to all bearings and moving parts, reduces friction and heat. Four-stroke engine can drive the propeller through a gearbox. Or it can also serve as a genset by having a generator attached to it. The engine can be installed in different ship layouts: a single engine, twin engines for more power, multiple engines driving generators that power electric motors, which in turn rotate several propellers positioned around the ship. Thank you for watching. If you know anything more about this topic, please leave a comment below. My name is Lucius, and I'll see you in the next video.